Alright guys, welcome back. We'll be discussing logarithm functions in this video. But before we get into that, let's start with just kind of, see if we understand what log is in terms of the notation, in terms of what it means. So when you do see, logarithmic expressions in the future, instead of just looking at it as a log, you common sense, it has a certain meaning, and we just have to know what that meaning is in order for us to, feel like it's okay to just kind of do these problems, or actually not afraid of log, because I know a lot of students are they're very strong dislike toward logarithms, and I think most of it is just not understand what it is, the notation itself. So let's get to it. Suppose we have this exponential equation here, 2 to the x equal to just 4, something is that simple. So we have to figure out what x is. 2 raised to what power equal to 4? Well, we know that x is equal to 2. Why? Because 2 squared equal to 4, right? So pretty easy. But what if we have an exponential equation such as this here, where we try and find x such that 2 raised to x equal to 3. Well, you may think that, well, this is kind of hard to figure out. There's no whole number such that 2 raised to get 3, because 2 to the first is 2, right? We know that x has to be between 1, because 2 to the 1 is 2, and then 2 to the 2 is 4. So to get 3, it has to be a number between 1 and 2. But it's not a whole number, and it's not a decimal. Well, it is a decimal number. It's not a rational number. It's one of those numbers where we have to use calculator to actually get the estimate value of x. But essentially that's what logarithm was created for. This is to being able to write x in an exact form, so that it fit perfectly in this equation here, right? So in this problem, in this example here, x is between 1 and 2. We know it's between 1 and 2. So what we can do here is we can say x is, to solve for x is a power such that 2 raised to get 3, right? So that's what the solution for that equation is, right? And then we kind of rewrite this language here, this English language, in terms of mathematics, and we say, okay, well, what that means? Well, x, okay, means equal, right? A power, such that 2 raised to get x, 2 raised to get 3. Well, what we can do is x is equal to, so we're gonna go ahead and just capture this phrase here using a notation. We say x is the power, or a power, such that 2 raised to get 3. Okay, so what we just did there is we kind of give this phrase here a notation, logarithm notation, log. 2 is a subscript right underneath the log here, and 3 is what we have to raise 2 to raise x 2 to x to get 3. So this phrase here is kind of captured, that it's been captured using this notation, and that's all it means. Is when you see log, it just means, okay, what is the power I'm looking for? The power such that 2 raised to get 3, right? So this here, this equation, or this expression here, this equation is equivalent to this. It's another way of looking at it, okay? But by writing x in this answer here, we capture what x is in terms of its exact form, not just an estimate value, not just some decimal that rounds to a certain number. You know, with today's technology, we can actually get x to the precise value of decimal number. But back in the day, there's no calculator, and all we can do is just express x in its purest form or in its exact form, just like when you have the square root of 3. We don't know what that is in terms of the right decimal value, but if we leave it how it is, that is in exact form. So that's what we do in this chapter or this lesson, is that introduce the notation log. Has certain meaning in English, and all we have to do is just remember that meaning in English, and we can solve logarithmic problems or equation and not be afraid of it. It's just a language that we have to learn, really. So going back to this here, this is being written more formally. It said for the meaning of log base a of x. So for x greater than 0, a is a positive base or constant other than 1. Log base a of x is the exponent, right? So this expression is the exponent to which the base a must raise in order to get x. Okay, so if we have this here is the exponent where a raised to get x, call that exponent m, then this form here now become a raised to that exponent m equal to x. So this is the equivalent. The two forms are equivalent. One is a log form, the other one is exponential form. So before we get to the graph here of what log base 3 graph look like, let's just practice and write these exponential equation as logarithmic equation and kind of get used to the notation itself. Okay, so this is in log form. Okay, now if this is in log form, we use a definition, and then we're going to get that into exponential form. Okay, so we're going to say, okay, well, this is saying that y is log base 2 of 16. Well, this is saying that y is the exponent for which to raise to get 16. That's what it's saying. So now we're going to rewrite that phrase there using mathematics equation or notation that, what that means. Okay, so now this become y is the exponent for which 2 raised to get 16. Well, what that means is 2 must raise to y, because it's the exponent, equals 16. Well, if we were to solve it, it's not asking us to solve it. If we were to solve, in this case, it's going to be 4, because it's an easy exponent we can guess, right? But really, we should practice from this form to that form in a way where we're fluent with it, and that way we look at log in the future. So, okay, that just means it's just an exponent of something, right? So it's not something foreign. It's not something that super complicated for us to understand. It's just a notation that stands for something. We must know what that definition, that notation is, and we should be okay, right? So let's move on to the second part. Here. This is in log form. Sorry, we're gonna convert this into exponent form or exponential form. So now we said -2 is equal to log base a 1/4. What this means, right? I'm just gonna write one more time so we kind of get used to notation. What this means is that -2 is the exponent that 1/4 raised to get excuse me, let me go back. I think that that a, which is the base, raised to get 1/4. Okay, so now we're just gonna go ahead and rewrite that part. We say, okay, what that means is -2 is the exponent that a raised to get 1/4. So a must raise to -2 to get 1/4, and so that's what we are doing there. Okay, I'll let you do part C on your own. But now we're going backwards in exercise 3. We're given exponential equation or the form, and then we're gonna write the equivalent logarithmic equation, in a way that solve for this. Well, if we were to solve for this, we know x is 3 in this case here, right? 2 to the third is 8. So we know that already. But we're going to go from that to log form. So we're going to say, okay, 8 equal 2 to the x. So we always start with the exponent, right? We always start with the exponent. We say, okay, x is the exponent such that 2 raised to get 8. Right? So x is the exponent, what 2 raised to get 8. So the log part, it just referring to the exponent such that 2 raised to get 8. That's just all that means, same thing there. Okay. Part B, again, start with the exponent. We're going to say -1 is the exponent. Okay, so -1 equal log such that the base 4, not the base in this case. So -1 is the exponent that y raised to get 4. Okay, so we start with the exponent and then we do equals and we do log and we start with the base. The base is the thing that raised to the power, right? So part C, I'll let you do it on your own here, but feel free to pause the video and try this and then come back to the video. So again, we start with the exponent. Exponent is b, so we're going to say b is the exponent such that the base a raised to get c. Okay, or you can try and memorize this definition here and just kind of go by it. That's something I would do too. When I first learned this, is just kind of memorize that. Okay. So in exercise 2 and 3, we talk about how to go back and forth between two forms, because it's going to be really important for us to really solve anything down the road is looking at logarithmic expressions or equation and understand what it's asking. I think that's really important. If we don't know the notation and definition and we look at this here, we're going to have no idea what these guys are really saying, what that even mean, right? I'll do one example and I'll let you finish the rest here. These are just solving just basic log equation, okay? So we have to find x. In this case, solve is always solve for x, right? So it is saying that log base 2 of x is equal to -3. Well, this log equation has a meaning in exponential equation. So we apply the definition. We say, okay, well, -3 is the exponent that 2 must raise to get x. So we apply the definition. We say, okay, well, this form now becomes 2 must raise to the exponent to get x. So therefore, x is 1/8, right? So go ahead and practice that on B and C and D there, okay? And we'll go back to the graph of log perhaps in the next video. But I'm gonna pause on this video here and we'll go over the graph in the next video.